letter E. And by E, I mean E, that kind of E, the kind of E that we use in the continuous compounding interest formula. And I'm going to talk about where does that number come from? How did we figure out what that number should be? By the way, it's around 2.71, blah, 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 blah. So anyway, first of all, E stands for Euler's constant. Euler, he pronounced it, oh, that's my dog Peanut. Go away, Peanut. Euler's constant. Euler, he was German, so that's how come he says his name funny and spells it weird. It doesn't look like it should say that, but it does. It says Euler's constant. Euler. So anyway, where did he get the number 2.71 blah, 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 blah from? Let me tell you. Let's talk about this. We really wish this could happen math problem here. You invest $100 in an account with 100% APR. That means how much interest rate are they going to give you over the course of a year, kind of thing. How much will you have depending on how often the interest is compounded? Basically, how many times do they pay you interest, and then that interest starts making interest of its own. And first of all, this would never happen. If it did happen, nobody would ever go to work again, because you're never going to get 100% rate of return in a year. You're never going to double your money in a year. Well, maybe you will, but not in a normal bank account, whatever. So anyway, let's figure it out. So let's say we were only going to compound or earn our interest once. Well, we would use our formula. You know the formula. The ending amount equals the beginning amount times 1 plus the rate over the number of times to compound raised to the number of times to compound times time, and time is usually the year. So if we're going to use that formula, let's fill it in here. So our ending amount, which is what's going to go over here, equals the beginning amount, that's your $100, times 1 plus, now our rate is 100%, but we need to convert it into decimal form. So 100% in decimal form would just be 1. So 1 over the number of times to compound. So we have different choices here, but on this one we're just going to calculate it for 1. Raised to the power of the number of times to compound again, times time. And we said we were just going to keep it for, oh, it didn't say, but we're just going to keep it for 1 year in all these examples. So if you were to figure that out, it would basically come out to 100 times 2, and your ending amount would be, at the end of the year, $200, which is not bad. But what if you were to earn your interest more often? What if you were to earn it twice in the year? So they pay it like once in June and then once in December. All right, same thing. So 100 times 1 plus your rate over, but this time we're going to compound it twice, times 2, and then we're still just going to leave it in there for a year. If you were to do that, I've already prefigured it out here, you'd have approximately $225. So already we can see the more times you compound, the more money you get. So it's like, all right, let's just keep compounding then. What if we do it for 5 times? If you do it 5 times, if you compound 5 times in a year, you get 248.83. I feel like this board's gonna fall over, let's hope not. If you do it 10 times in a year, compound 10 times in a year, then you get $259.37. Okay, so again, the more we compound, the more money we're going to have. So we're about to really ramp it up here. We're going to compound 100 times. I'm expecting buku bucks. Let's find out. So if I compound 100 times in a year, how much money am I going to have? I'm going to have $270.48. $270.48. Super. Okay, now I'm about to compound literally every single day of the year, 365 times. I'm expecting this to be so much money. I'm so excited. Sign me up for this bank account. Here we go. drum roll. How much money am I going to have? What? I'm only going to have $271.46. You mean I took it from 100 times of compounding, like once every 3 days compounding, to once every single day compounding, and I got less than $1 worth of improvement? Are you kidding me? Well, that's what Euler's constant is. Euler's constant is somewhere around 2.71 blah 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 blah, and it basically is the limit. Like, no matter how much you compound, if you were going to compound daily, if you were going to compound by the hour, if you were going to compound by the minute or the second or the nanosecond, eventually you'd reach a limit of how much you could earn, and that would be, your rate would be about 271% of what you had started with. So that's what Euler's constant is. And you might get asked that on a math test, and now you know, and now you can impress your friends with your knowledge. And thanks for watching. And if you need tutoring, remember, I'm only a click away. Just go to my website, contact me, and let me know if you need one-on-one tutoring. Thanks for watching. Hey guys, don't forget to like, subscribe, and check out my website at oliviashirleytutoring.weebly.com, where you can schedule one-on-one tutoring and contact me.